Hello guys, hope you're feeling well. This is Wael Bashuri, the physics teacher. In this video I'm gonna solve this paper, MCQ multiple choice, paper 1, code 9702, version 12, February, March 2024. So let's directly start with the first question. Which row shows a physical quantity and its base unit in the SI system? So here you have the quantity, current ampere, this is base, this is SI base unit. So option A is the correct answer. In option B, force is Newton, this is derived unit, it's not a base unit. Option C, gram is not the base unit, it's kilogram. So also this is incorrect. Also Celsius is not the base unit, it's Kelvin. So you have to memorize the 7 SI base units. Question 2. A car of mass 850 is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has magnitude 1200 newtons and the other force has magnitude 1600 newtons. What's the magnitude of the acceleration of the car? So here you have to use the Newton's second law of motion, which states that F net or resultant force is equal to mass times acceleration. Resultant force in this case is 1600 minus 1200 is equal to the mass, which is 850, times the acceleration, which is A. A will be in this case 400 divided by 850, and this is option A. Question number 3. An object of mass m is suspended by a spring from a fixed point. The spring has spring constant k. The object is set into vertical oscillation of period t. Which quantity for t is homogeneous with respect to the two base units? In order for an equation to be homogeneous, it must be the units on the left equal units on the right. Units on the left here is second, period is measured in second, is equal to 2 pi, we ignore it because it's unitless. K is the spring constant, it's Newton times meter to the power of minus 1 divided by mass, it's measured in kilogram. Now we know that Newton is mass times acceleration, so we can say second is equal to Newton is mass times acceleration, which is kilogram times meter to the power of negative 2 times meter to the power of negative 1. Of course here per second divided by kilogram. So if you cancel kilogram and kilogram, and then if you cancel meter with meter to the power of negative 2, clearly this will not be equal to second, so option A is incorrect. If you check option B and C by the same way, you have to conclude that these are also incorrect. Let's check together option C. So here you have T is second, 2 pi, we ignore it as we said, square root, mass is measured in kilogram, and K is Newton times meter to the power of minus 1. So let's write it, Newton times meter to the power of minus 1. So second is equal to square root kilogram. As we said, Newton is kilogram, let's write it here, force equal mass times acceleration. So Newton is kilogram times meter second to the minus 2. So here you write kilogram times meter second to the minus 2 times meter to the minus 1. Now you start cancelling. You can cancel kilogram and kilogram. You can cancel meter and meter. And you can take second to the numerator, and you write it this way: second equals square root of second power of 2. So this means left equal right. Option D is the correct answer. Question number 4. An object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it's moving? The resultant force acting on the object when it's moving. Now here we know that force is directly proportional to acceleration according to Newton's second law of motion. So clearly it increases uniformly. No, it doesn't increase. It's constant. Because the acceleration is uniform, so the force must be constant. It cannot be increasing. So it's constant but not zero. This is the correct option. It's proportional to displacement from point B. No, it's proportional to acceleration. It's zero, it's not zero. So option B is the correct answer. Question number 5. A projectile is launched at an angle 25 degrees to the horizontal with a horizontal component of velocity of 13 meters per second. What is the vertical component of the velocity of the projectile when it's launched? So in order to solve this question, let's sketch it. A projectile is launched at an angle 25 to the horizontal. So this is the direction of velocity, 25 to the horizontal. With horizontal component of 13. So here you are given the horizontal component 13 meters per second. What's the vertical component of the velocity of the projectile? The vertical component here, Vy, is unknown. Vy is unknown, and here you have V, the velocity of the projectile. In order to solve this question, let's take the components Vx and Vy. Vx is equal to V cosine 25. And we know that Vx is 13, so we can say 13 is equal to V cosine 25. Now the vertical component is Vy, so we can say Vy is equal to V sine 25. So here we can easily find Vy. If you divide 13 by Vy, or if you divide second equation by first equation, Vy divided by 13, you get tan 25. So now you do cross multiplication, 13 times tan 25, and then you get option B. Let's see now next question. A ball is released from rest at position X at time 0. At 1 second, it bounces inelastically from horizontal surface and rebounds, reaching the top of the first bounce at 1.5 seconds. What is the total displacement of the ball from its original position X at 1.5 seconds? Okay, so here we're asking about displacement. A ball is released from rest at position X. So let's draw a diagram. A ball is released from here, which means now it's falling down. Which means this area initially u equals 0, velocity initial is 0 as here stated in the graph. So initially the speed is increasing with constant acceleration, which is the slope of the graph, which is clearly rise over run, which is clearly 10 meter per second squared. That's the acceleration. In order to know the displacement down, we have to find this area. So area under graph is the displacement down. So half times 1 times 10. Half times 1 times 10, which is 5. So initially it has fallen 5 meters. So 5 meter. Then it bounces and goes up. So now here it bounces from the floor and goes up like this. What distance does it go up? That's the distance. We can find this area here in order to find distance up. So let's calculate this area. Area, as we said, area of triangle, half base height. So area is equal to half times the base. The base is from 1 to 1.5. So this is 0.5. Half times 0.5 times the height, which is 5. So here the height is 5. And this will be 1.25. So clearly it has fallen a distance of 5 and bounces up a distance of 1.25. So here 1.25. So now the displacement will be this distance from here to here. That is the displacement. So distance from starting position is the displacement. So clearly you have to subtract 5 minus 1.25, and option B is the correct answer. Let's now see question number 7. What is the definition of acceleration? Definition of acceleration is change in velocity per unit time. Clearly option A is the correct answer. Rate of change of speed per unit time, this is not the definition of acceleration. Rate of change of velocity per unit time is wrong. Resultant force per unit mass is wrong. Question number 8, momentum question, clearly. Two balls P and Q of equal mass move along a straight line directly towards each other as shown. Ball P has velocity 1.30 meter per second to the right. Ball Q has velocity 0.50 meter per second to the left. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after collision? So if you note here, the collision is perfectly elastic. This means relative speed of approach must equal relative speed of separation. So relative speed of approach, we can find it from the diagram here. So we can see 1.30 minus 0.50, and this is 1.80. So now let's see which one of the options has a relative speed of 180. Clearly option D is the correct answer, because here we also do the same thing. Speeds are in opposite direction. So if you find the relative speed of separation, also you find it exactly the same. While here speeds are in the same direction in A, so you have to add them. So if you add them, you won't get 1.80. The same thing with respect to B, the same thing with respect to C. In C you have to subtract them. For example, you can see 0.99 minus minus 0.19, which is not 1.80. Question number 9 now. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.90 meters. Air resistance is negligible. What's the speed of the ball as it hits the ground? So here air resistance is negligible. This means you have constant acceleration. Acceleration is constant. So you can use equations of motion. Motion is straight line, acceleration is constant. You can use equations of motion. So v squared is equal to u squared plus 2as. So v is equal to square root u squared is given in the question 2.4 squared plus 2 times 9.81. That's the gravitational acceleration times distance or displacement moved, 0.90. Option B is the correct answer. Question number 10. A ball falls through a liquid at constant speed. It is acted upon by three forces: an upthrust, drag force, and its weight. The liquid has uniform density. Which statement is correct? So let's draw a diagram for the ball. This is the ball. It's falling through a liquid, so the weight is downward force, and drag force will be an upward force because it's opposing the motion. So this is drag force, which is friction with the liquid. Also you have the upthrust, which is also an upward force acting on the ball. This is the upward force. Let's see the options now. The drag force increases with increasing depth. Drag force depends on velocity, so it's not increasing or decreasing because it's moving at constant velocity. The drag force is equal to the sum of upthrust and weight. This is incorrect because the weight itself is equal to upthrust plus drag force. Option C, the upthrust is constant with increasing depth. This is the correct answer. The upthrust is constant, does not change, because upthrust is equal to rho g v. So it does not depend on the depth, so it's constant. The weight is greater than the sum of the drag force and the upthrust. This is wrong because we said that the weight is equal to drag force plus upthrust, because it's moving at constant velocity. Question number 11. Some small solid cubes each have mass 1 kilogram and side length 5 centimeters. These small cubes are stacked together to form a large solid cube with sides of length 2 meters. What is the weight of the cube? So here let's first find the volume of the big cube. Volume is equal to 2 to the power of 3, which is 8 meter cube. This volume of the large. Now volume of the small is 0.05 to the power of 3. And this is 1.25 times 10 to the power of -4. Now if you divide the volume of large by volume of the small, this volume of the small, you can get number of cubes. So number of cubes will be 8 divided by 1.25 times 10 to the power of -4. And this will be 64,000 cubes. Now the question is asking you to find the weight of the large cube. So let's find it here. W is equal to mg. W is equal to the mass of all of them, mass of all the cubes. So 64,000 times the mass of one of them, which is 1, times G, which is 9.8. So the answer here will be option C. Yes, let's have another color. Option C here is the correct answer. Let's see now next question. Number 12. A borehole of depth 2000 meters contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. The density of oil is 830 kilogram per meter cube, and the density of the water is 1000 kilogram per meter cube. What is the depth x of the oil? So in order to solve it, we start like this. Pressure at the bottom is given to us here. So let's see what we have to do. Pressure at the bottom is equal to pressure due to oil plus pressure due to water. So pressure at the bottom is given to us is equal to pressure due to oil is rho G and H. H here is X. That's what we have to calculate. Plus pressure due to water is rho water, this is rho oil, times G times the depth for water. Depth of water is from here to here, which is 2000 meters minus X. So let's write it here, times 2000 minus X. Now we replace 17.5 here. Mega means million, so times 10 to the power of 6 is equal to density of oil 830 times 9.81 plus density of water, which is 1000 times 9.81 multiplied by 2000 minus X. Of course here times X, here times X, rho G X. Now the only unknown in this equation is X, so you can solve for X and find the answer. And if you solve for X, you can get option D. Question number 13. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0. The weight of the rod causes a moment about the pivot. The rod is then rotated in a vertical plane so that the angle theta of the rod increases from 0 to 180. Which graph shows the variation of M with theta? So let's draw some diagram for the initial position of the rod. Initially, this is the pivot. The rod is making angle theta with the horizontal. Here you have the weight. The weight is exerting. The weight of the rod causes moment M. So that's the weight of the rod. So that's the initial position of the rod. Now, next, if you draw the rod again at an angle 90, if you increase the angle, so now the angle becomes 90 to the horizontal. That is the horizontal direction. Here initially the horizontal direction is this. Now it makes angle 90 with the horizontal, so angle theta has increased. So now the moment of the weight is downward force. The weight now passes through the pivot, so now it's not exerting any moment on the rod. Final position is when the rod is this way. So now the weight is here. Now the angle with the horizontal is 180. So here the angle is 0, theta equals 0, theta equal 90, and here theta equal 180. So the rod has moved this way. Theta has increased. So here we know that the moment is equal to force, which is W, times distance from the pivot, which is this distance D. And here we'll add another term, which is cosine theta. Cosine theta. Cosine 0 is 1. So initially the moment will be WD cosine 0. So moment is equal to W times D times cosine 0. Why we're adding this cosine? Because now in this question the moment depends on theta. Now what about the middle graph? In the middle graph theta is 90, so the moment will be W times D times cosine 90. Cosine 90 is 0, so the moment here will be 0. So this means the moment was maximum, then it becomes 0. So we cross option A is out, cannot be constant. The moment cannot be constant. So it was maximum, then it becomes 0. And in the last graph or last diagram here, the moment is acting in the opposite direction, because here initially the moment here is clockwise. In this diagram the moment is clockwise. Here the moment has become anti-clockwise, which means in the opposite direction. So initially it was maximum, then it becomes 0, and then it becomes maximum again in the anti-clockwise direction. And as we said, this is cosine curve. So which means option D is the correct answer. Question 14. A hinged trapdoor is held closed in the horizontal position by a cable. 3 forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the force H at the hinge. Which list gives the 3 forces in increasing order of magnitude? So in order to solve this question, I will take some moments. So first step, if I take moment about H here, if I consider the pivot to be here, in this case I have 2 forces. H will be cancelled because it passes from the pivot, or because the distance from H to the pivot is 0, so H is cancelled. Now I have 2 forces, W and T. Here I have to split T into 2 components, vertical component and horizontal component. Horizontal component also has distance T horizontal. It has distance 0 from the pivot, so it's cancelled. It's not considered here. So let me cancel it from the diagram. Only the vertical component will be acting. So in this case, W times its distance from the pivot is equal to T vertical times its distance from the pivot. Clearly, this is dt, this is dw. Clearly, W and T, if you compare them, which will be greater? In fact, the one which has greater distance is the least. So W, we can conclude that W is less than T. So this means I can I can cancel option A and B from the options. These are wrong because W must be less than T. Okay, now let me take another pivot in order to compare T and H. Let me consider the pivot to be here at W. In this case, W is not exerting any moment because it has distance of 0 from the pivot. Now to compare these two forces, I can take vertical component of T and horizontal component of T, and also same thing for H, horizontal and vertical components. We know that the horizontal components of both of them has distance of 0 from the pivot, so we can cancel horizontal component and compare the vertical component. The distance from the pivot for T is smaller than the distance of the from the pivot of H. Distance of H from the pivot is bigger. Bigger distance means less force. This means T is less than H. Sorry, T is greater than H because T is closer to the pivot. So it must be the biggest force or bigger than H, which means option C is the correct answer. Question number 15. What is the definition of force? Definition of force is rate of change of momentum, so option C is the correct answer. Number 16. A boat moves at constant velocity v through still water. A constant drag force acts on the boat. What's the power used by the boat to move through the water? We know that power is equal to work divided by time. And work is equal to force times distance. So divide by time. We know that force times distance, force divided by distance is velocity. So we can say it's equal to force times velocity, and option B is the correct answer. Question 17. Diagram shows 4 forces acting on a circular disc. Each force has magnitude F. 2 of the forces act vertically and the other 2 forces act horizontally. All 4 forces act at the same plane as the disc. No other forces act on the disc. The disc has diameter d. Which statement is correct? Okay, first option. The disc is in equilibrium because the resultant force is 0. For equilibrium, we should have resultant force equals 0 and moment equals 0. But clearly here, resultant force is not 0. So here this option is incorrect. The disc is not in equilibrium because the resultant force is 4F. When there is a resultant force, it's true that the disc will not be in equilibrium. In fact, resultant force is not 4F. Resultant force equals 0. Sum of forces is equal to 0 because here you have these 2 forces can cancel each other and these 2 forces can cancel each other. Upward forces equal down forces and forces to the right equal forces to the left. So clearly it's incorrect. Question C. The disc is in equilibrium because the resultant torque is 0. Clearly the disc here is rotating in a clockwise direction, so resultant torque is not 0. Option D. The disc is not in equilibrium because the resultant torque is 2Fd. This is correct because if you calculate the torque is one force, so torque is equal to one force times distance between them. So here, let's say this is distance d, so F times d plus F times d. and this will give you 2FD. Question 18. A ball is projected into the air from horizontal ground and follows the path shown in the diagram. Path of the ball is shown in the diagram. Okay, so all at points Q, R, S, and T, the ball has kinetic energies EQ, ER, ES, and ET respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Which difference in kinetic energies is the smallest? Since air resistance is negligible, so the smallest difference in kinetic energy will be also smallest difference in gravitational potential energy. So let's check one by one. EQ minus ES, Q here 1.5 and S is 1.6. So if you find a difference in height, difference in height will be 0.1. For B, ES, ER, ES and ER, so we have to compare this one and this one, and the difference would be 0.2 meters. Next one, ET, EQ, so we have to compare T and Q, and the difference is again 0.2 meters. And then for T and R, T here and R here, the difference is 0.5 meter. Clearly option A is the correct answer. Question number 19. The battery of a small tablet computer is initially uncharged. It's connected to a constant 10-watt power supply for 2 hours to charge the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? So we know that efficiency, which is 80%, is equal to power output over, or useful energy output over power input. Power input here is 10 times 2 times 3600. Power output, power input is energy. Energy input is power times time, and here you have X. So then you cross multiply, so you get X is equal to 5.8 times 10 to the power of 4 joule, which is option C. Question number 20. An initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. One fragment has mass m and the other one has mass 2m. What's the speed of the fragment of mass m immediately after the explosion? So here you have the object initially, the firework, which consists of these 2 parts, 2m and m. This explodes so into 2 fragments. One goes to the right, other one goes to the left. Let's assume that 2m goes to the right and m goes to the left. So initially, momentum before collision equal momentum after collision. Momentum before collision is 0. It was at rest. Then momentum after collision is mass times velocity. So mass 2m has traveled to the right, so 2m 0 is equal to 2m times its velocity, let's say v1, plus m times its velocity, which is v2. Now the equation for kinetic energy as stated in the question. Kinetic energy is equal to half times 2m times v1 squared plus half times m times v2 squared. The question here is, what is the speed of fragment of mass m? Mass m means we are looking for v2 here. We want to find v2 here. So that's the question. So what do we need to do? We need to find m1 in terms of m2, and then we plug it in here. We plug it in the equation. So from the first equation, let's find v1 and plug it here, and then we solve for v2, which is the speed of m. That's the requirement in the question. So let's see what we can do. From this equation, we can conclude that if you cancel the m, because you can divide by m all sides, so you can cancel m. So you got 2v1. Of course, here the sign must be minus because they are in opposite direction. So you can say 2v1 is equal to v2. So 2v1 is equal to v2. Now I need to find v1. So I can see now v1 is equal to v2 divided by 2. Now let me replace this amount here in v1. So kinetic energy will be half times 2 is cancelled, so you can cancel here 2 and 2. Mass times velocity, so you can see mass times v2 over 2 plus half times mass times v2 squared. Of course, here you have also squared. If you continue now simplifying, you get energy is equal to 1 over 4 mv2 squared plus half mv2 squared. Energy is equal to 3 over 4 mv2 squared, and this means 4 over 3 energy over m is equal to v2 squared. Now if you take the square root of this amount from both sides, 4e over 3 square rooted, so v2 is equal to square root 4e over 3m, and this is option D. Let's see now next question. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct for this spring? We know that kinetic energy. We know that potential energy is equal to half kx squared. So clearly potential energy is directly proportional to the extension, which means to the square of the extension, which means option D is the correct answer. Question 22. A force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? First statement, the point at which the wire breaks. This is incorrect. The point beyond which Hooke's law is not obeyed. This is correct. What must describe the limit of proportionality? This at this point, it's the point up to which the graph is a straight line. So option B is the correct answer. C, the point beyond which wire cannot return to its original length. This is not the limit of proportionality. The point beyond which the wire starts to deform plastically, this is also wrong. 23. A spring has spring constant 6 Newton per centimeter. It's joined to another spring whose spring constant is 4 Newton per centimeter. A load of 18 Newton is suspended from this complete spring. What is the extension of the composite spring? We know that according to Hooke's law, force is equal to kx. Now let's apply this to each spring. The load in both cases is 80, so here you have 80 is equal to constant, which is 6, times the extension, we don't know. So like this we found first extension. So in order to calculate first extension, let's call it extension 1. You can say x1 is equal to 80 divided by 6. Now extension 2, you can use the same logic. For extension 2, it's 80 divided by the constant, which is 4, and this will be 20. Now 80 divided by 6 is 40 divided by 3, which is almost 13. So if you add 13 plus 20, you get option D. Of course, there's another way of solving this question. You can find the combined constant, 1 over k combined or total is equal to 1 over k1 plus 1 over k2, because these two springs are in series. So 1 over k total is equal to 1 over 6 plus 1 over 4. Then after simplifying and having same denominator, you can get 4 plus 6, 10 over 24. This is 1 over k total. So k total will be 2.4 Newton meter to the minus 1. Then you can say force is equal to kx. Now x here is the total extension, because k is total constant and F is total force. So 80 is equal to 2.4 times total extension. If you solve for the extension, you also get option D. Question 24. The range of frequencies of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of sound in seawater is approximately 1.5 km per second. What's the approximate range of wavelength of sound waves emitted by the blue whales? So here we have to find the range of wavelength. So V is equal to F lambda. That's the equation you have to use. Velocity is 1500 multiplied by 1000 is equal to frequency, which is initially 10 times lambda. From this equation you can get lambda is equal to 150. For the other frequency, 1500 is equal to 40 times lambda, and from this equation you can say lambda is equal to 38, which means option D is the correct answer. Question number 25. Sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope, CRO. The frequency of the wave is 2.5 kHz. What is the setting on the time base of the CRO? Which means what is the time base setting? First of all, I need to know here that the period of one wave is 4 divisions. 1, 2, 3, 4 divisions. So period T is equal to 4 divisions. Now we know that frequency is equal to 1 over period, and period is equal to 1 over frequency. So I can say here 1 over 2.5 times 10 to the power of 3, that's the period, 1 over frequency, is equal to 4 times 1 division. 1 division, that's the requirement in the question. So if you solve for x here, you get x is equal to 1 divided by 4 times 2.5 times 10 to the power of 3. X is equal to 10 to the power of -4 second. And if you convert into millisecond here, clearly the option D and C are incorrect, so you have to convert into millisecond. So in order to convert from second into millisecond, you need to multiply by 1000. So x is equal to 10 to the power of -4 times 10 to the power of 3 is equal to 10 to the power of -1 millisecond, which means option A is the correct answer. Question number 26. A source of sound waves with constant frequency moves towards the stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source of sound. What is detected by the observer? So here this is Doppler effect. So let's see which option is correct. The source of sound wave with constant frequency moves towards the observer. So if this is the observer and the source of sound is moving towards the observer, this means the observer will receive wavelength, short wavelength with higher frequency, because the diagram would seem like this. Okay, so the observer will feel a high frequency, and when frequency increases, wavelength decreases, because V is equal to F lambda. You can see when F increases, lambda decreases. So the wavelength will be a decreased wavelength, so he will receive decreased wavelength, which means option C is the correct answer, decreased wavelength of the sound waves. Question 27. Which type of waves cannot be polarized? Clearly, sound waves cannot be polarized. So option B is the correct answer. Because sound is longitudinal wave, it cannot be polarized. Question 28. A beam of light with power P has an area of cross-section A. The amplitude of the light waves in the beam is X. The beam of light is then changed to 1 with the same frequency but with an increased amplitude of 4x and an area of cross-section reduced to A over 3. What is the power of the new beam? So here we know that intensity is equal to power divided by area, and we know that intensity is directly proportional to the amplitude square. So if the amplitude has increased to 4x, it means intensity will increase by 16 times. So intensity will increase by 16 times. So here you can rearrange this equation to get power is equal to intensity times area, because here we need the power of the new beam. So intensity has increased 16 times and area has decreased 3 times. So power is equal to 16 divided by 3, which means option B is the correct answer. Number 29. Two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that the stationary sound wave is set up in the region between the loudspeakers. A microphone is connected to a cathode ray oscilloscope CRO and positioned between the two loudspeakers. The microphone is moved along the line joining the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes. As the microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the fifth maximum. What is the wavelength of sound wave? So let's draw in the region between the two loudspeakers. Let's draw the 5 maxima. So let's take some nodes first. 1, 2, 3, 4, 5, 6, 7. So let's draw the stationary wave between these two loudspeakers in this region. Now this is the stationary wave observed. Now we have to move the microphone from the first maxima to the second maxima and take 2 centimeters. Let's choose any maxima. For example, if you choose this maxima here, this maxima, so this is first maxima, 1, 2, 3, 4, 5 till here. So from here to here, how many waves do we have? This is one wave, and this is another wave here, another 3/4 of a wave, and here you have 1/4 of a wave. So all of them will be 2 waves. And this distance, we are told in the question that this distance is 2 meters. So if you divide 2 meters by 2 waves, 2 meters divided by 2 waves is equal to 1. So option D is the correct answer. Question number 30. Two wave sources emit coherent waves. Which condition must be correct to the coherent waves? Which condition must be correct to the coherent waves? We know that the coherent means constant phase difference, so we can directly choose C. The waves are emitted with constant phase difference. Question number 31. A student sets up an experiment to investigate double slit interference. The student uses light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of fringes on the screen? Here you have to write the formula. Lambda over A is equal to X over D. If you can rearrange it, you can write it lambda equals to AX divided by D. But here you are given different letters from the formula in the textbook. So what you have to do here, so let's choose the letters given in the question. Lambda is equal to Rx divided by Q. So what could the student decrease in order to increase the separation of the fringes? So our target is to increase the separation of the fringes. We know that R and X are inversely proportional. X and Q are directly proportional. So to decrease the separation, you need to do here what could the student decrease in order to increase the separation? So I want to increase X. clearly C is the correct answer. The separation of R must be decreased because, as we said, R and X are inversely proportional. They are on the same side of the equation. Question number 32. What are the definitions of potential difference PD and electromotive force EMF in terms of energy transfer W and charge Q? We know that EMF is energy per unit charge, and PD is also energy per unit charge. So both definitions start the same way. Option A is the correct answer. Question 33. Diagram shows network consisting of 3 resistors. What's the combined resistance of the network between X and Y? First step, you have to find combined resistance of the parallel branch or parallel resistors. So you can see 1 over R total for this branch is equal to 1 over 1.2 plus 1 over 4.7. If you do the math now, you get R is equal to, so here you get 0.95. Then the total resistance or the combined resistance is 0.95 plus 2.2, and option C is the correct answer. Question number 34. A resistor dissipates 25 watts of power when there is a potential difference of PD of 4 volts across it. What's the resistance of the resistor? So here we know that power is equal to V squared over R. The power is given to us 25. V squared is 4 squared divided by R. If you rearrange the equation, you get R is equal to 16 over 25. So option B is the correct answer. Question 35. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. What happens to the potential difference across the variable resistor and the current I in the variable resistor? So let's see what happens here. The resistance of the variable resistor is decreased. So here you have R has decreased. When the resistance decreases, it will take less share of the voltage. This means the voltage will decrease. Option A or B will be the correct answer. Now when the resistance here decreases, this means total resistance, total R, will also decrease. Total resistance in the circuit will also decrease. And if the total resistance decreases, a higher current will flow in the circuit, because R is equal to V over I. When total resistance decreases, total current will increase. So this means option B will be the correct answer. Question 36. Radioactive source produces a beam of alpha particles in vacuum. The average current caused by the alpha particles in the beam is 1.5 times 10 to the power of negative 9 ampere. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in time of 3 seconds? So the formula that we have to use here is Q equal IT. Let's find the charge. The total charge, we don't have it, so Q is equal to current, which is 1.5 times 10 to the power of negative 9 times the time, which is 3 seconds, and that will be 4.5 times 10 to the power of negative 9 coulomb. That's the total charge that's flowing in the as a result of the beam of alpha particles. So now we divide this number by the charge of one alpha particle. That's the total charge. So the number of alpha particles is the total charge 4.5 times 10 to the power of negative 9 divided by the charge of one alpha particle. Alpha particle consists of two protons, 2 neutrons. That's alpha. So 2 protons, charge of 1 proton is 1.6 times 10 to the power of minus 19 times 2. So 2 times 1.6 times 10 to the power of minus 19. If you do the calculation, get option C will be the correct answer. Question 37. The charge carriers of in a metal wire are free electrons. Which statement about the charge carrier of each free electron is correct? The magnitude of the charge increases with the potential difference across the wire. This is incorrect because the charge is not has nothing to do with potential difference across the wire. The magnitude of the charge is 0 unless the potential difference across the wire. Unless there is potential difference across the wire, again, there is nothing to do with potential difference and charge. The sign and magnitude of the charge do not depend on the potential difference across the wire. This is correct. So option C is correct answer. The sign of the charge depends on the potential difference across the wire. This is incorrect. Option C is the correct answer. Question 38. Which flavors of quarks have a charge of positive 2 over 3 E? Okay, we know here the charges of quarks. How many quarks we have? We have 6 quarks. We have charm, we have top, we have bottom, top, bottom. We have up, we have down, we have strange. Now these 3 have a charge of positive 2 over 3 E. And these down here have a charge of negative 1/3 E. Which means you can choose option A directly, which is very easy. Question number 39. An unstable nucleus of an element decays by emitting alpha particle or a beta particle to become a nucleus of different element. This nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope of the original element is produced. What's the minimum possible number of these particles emitted? So for the original element to appear again, or for the original isotope to appear again, we should have the same proton number at the end. So let's assume that initially we have the initial particle, or the initial nucleus was Z. So here you have the mass number is A and the proton number is P. Now this can decay by emitting alpha particles. Number of alpha particles we don't know. This is 4, 2. This is N alpha particle plus M beta particles, 0 minus 1, plus the other the same element appears again, which means X with same proton number P, but we don't know mass number, maybe it's different. Let's call it W. So now we have to focus on P, it should appear again. So now we can form an equation. The bottom numbers must be the same. So P is equal to 2N minus 1M plus P, because the bottom numbers must be balanced. Now you can cancel P and P from both sides of the equation. So you got here 2n equal 1m, which means here you have for every 2 alpha you have 1 beta, so you can plug now numbers. If you plug 1 here, in this case you can get minimum number of particles 3, so option B is the correct answer. Question 40 now. A nucleus of carbon 10 6 decays by beta emission to form a nucleus of boron 10 5. For this decay process, what's the change to a nucleon, and what is the change in the quark composition of the nucleon? So here you have carbon 10 6 has changed into boron 10 5, and this happens by the emission of beta particle 0 plus 1 for the numbers to be balanced. This is positive beta emission. So here we can see that a proton has converted to a neutron, which means an up down has converted into an up down down, and option B is the correct answer. Like this, we have finished this paper. Hopefully you have understood every explanation of all the questions, and I thank you very much indeed for listening till the end of this paper.